Good afternoon, everybody. I've got a bit of a cold, so my voice is a little bit different than it normally is. I'm Clare. I'm a project manager at the NCI. I'm presenting here today on behalf of Ben Evans, who wasn't able to attend due to another conference in Perth. Ben and the area that we work in, Ben's responsible for the data collections and data services and the lots of work we do around modelling software. We have a lot of collaborative projects with our stakeholders at NCI, many of which are represented in the icons, the logos at the bottom of this page. I'm just going to give you a little bit of a talk about the satellite data and remote sensing data that we have at NCI as part of our data collections, and in particular talking a bit about a data service that we've developed for improved access to that data. So first of all, at NCI we're actually a large repository of data. We've got more than 10 petabytes now. Mostly it's geospatial data that comes under the climate and weather, in particular environmental data sets, and growing Earth observations data. We also have some geophysical data, and then we also have astronomy, genomics and social sciences data, but that's sort of not a large part of our focus with the work that we do. Part of the reason we've created this data collection at NCI is because of the co-location of the data with the high-performance computing facility that we have at NCI. I should also acknowledge that the establishing repository of data at NCI was funded through a government program called Research Data Services, and that's done a lot to not just establish the repository but also the data services on top of it. So because of the co-location of these large data sets with the high-performance computing facility, a lot of our focus has been on improving interoperability of data so that we can have different domains, the data all working together. And obviously because of the size of the data that we're working with, it's actually improving the way research can be conducted and access to that data is scalable. That means that we've been doing a lot to work towards what's called findable, accessible, interoperable and reusable data, or FAIR data. I'm not sure how familiar people are with that. It means that we've put a lot of effort into managing the data in ways that make it easier for people to get access to it, to find it. It means defining the data sets that you have, cataloguing that data. What are the restrictions to access to that data, if any? Because obviously the more open and accessible the data is, the more people are able to use it for innovative purposes. We look to work of using common standards for describing the data, so that's metadata standards at both the catalogue and the data level, use of interoperable data formats, self-describing data formats and controlled vocabularies, because all of those things improve the way that you can programmatically access data. And it means that you're not searching through directory structures, because if you've got a good search functionality, you don't have to be knowing what project code that the data is in, and then trying to find your way around somebody else's directory structure, which if you think about the way most shared drives work, it can be quite difficult. In terms of the actual data we have in the satellite imagery and remote sensing, we rely a lot on the data that comes from our collaborators, and in particular Geoscience Australia, as Clare was already describing. We're doing a lot of work with the Digital Earth Australia with the Landsat data. It's been one of the best projects that we've had in terms of working with stakeholders to make that data more accessible and to make it fit for purpose for a range of use cases. And we've also done a lot of work with GA around the Copernicus Data Hub data to get access to the Sentinel data. More recently, we've done a lot of work with CSIRO, and particularly under the GeoGlam RAP project for MODIS data. And I always forget what GeoGlam means as an acronym. But the RAP part is the Range and Pasture Productivity Project. And I'm going to show some examples from that work, which is demonstrating one of our new data services as part of this project. But we're also working more closely with the IMOS and TERN teams to start working through this process of better documenting their data sets. And have also been working with the Bureau, and you can hear from Joshua soon about some of the radar data that we're looking forward to making available soon, and also with the Himawaari data. So if you want to find out more about the actual data that we have, you can use our GeoNetwork catalogue, and you can search for it there. If you don't find it there, you can always put in a request to our help, and you can say, do you actually have that data? And because sometimes data is available, but it just has not been put into the catalogue, and we can help chase that up. So if you want to access the data as well, these are the various data services that we have available. Just sort of mentioned there about the GeoNetwork, which is a data catalogue service. The main way people access data remotely at NCI is through the Threads OpenJAP server. Now that does have while it's the predominant or the primary way at the moment, it does have its limitations. And because of that, we've actually put a bit of work into developing what's called the GSKY service, and I'm going to describe that a little bit later on. And then we've also got GeoServer, which has some of our legacy data sets. Probably not sure how much longer. We haven't been really adding to that in terms of using it as a data server. And then Copernicus, which is the way that the Sentinel data is accessed. That's more just a data download service at this stage. And that metadata attribute search is one of the services we've developed that has actually enabled us to develop more advanced data services, which I'll talk about now. So with all of this large data that we're getting, and it's increasing to grow, I mean, we're finding already now that it's too big to move, so we're needing to come up with new ways of working with that data. And also we're finding that, if you're trying to use a whole lot of different data, in many cases, you're needing to manipulate that data, which has quite a high overhead on the work that you do. So what we've done is we've started to look at our data and start trying to cater for the variety of use cases that contributes to the interoperability, and trying to also solve that problem of not having to store data in multiple formats for specific uses, even though we know that that's what people are wanting to do. They want it to be suitable for their purpose. And then we also know that with a lot of work people do, they're wanting data from one area and to use it in another space. We're also finding that a lot of use cases are driven now by portals or apps and the tools that people are using to access their data. So what we've done is that we've actually put a bit of effort into developing a data service which can actually help to break down those the barriers for people accessing the different types of data, and in particular we're working on it as a remote access opportunity so that people can use other tools or portals and actually access the data without working specifically like being an NCI user. What we're aiming to do is just to make that the way that you query the data and then the return that you get to be a sort of more natural way of getting the data back, rather than being told, oh, here's a whole lot of files. We're actually being able to return the data in a way that's actually useful for the purpose. It takes advantage of that computational resource that we have, and by working with our end users, we're able to confirm that the way that the data is served is actually what was expected. We find that that's actually a really important, well, not only is it an important part, but it's really quite a consuming part in the initial publication process, but it's actually worth it because then we can have confidence that when people are accessing the data, it is what they're expecting. So now we've got what we're considering a production service takes advantage of the high performance computing, and it means that there's potentially less data movement, unless of course people really want to have a subset of that data for local use, but there's a lot of work that can now be done closer to the data rather than downloading. So the service that we've developed is called GSKY. It's a distributed geospatial data server. We're working with Digital Earth Australia for how we're displaying several data sets that have been developed through that project. We've been working with CSIRO, the Data 61 group for the National Map Data Portal. I'm not sure if people are familiar with that, but it's quite a simple tool for accessing data. And then also with CSIRO through their Land and Water to develop the GeoGlam data portal. We've also been testing GSKY working with other packages. Terrier.js is what underpins the national map, and building up the capability with Python. This is an open source code project, like the GSKY code is open source. If you want to find out more, you can look at that URL on the top of the screen. We have identified that we've got some issues with QGIS as a tool for visualising the data, but we're working on that to improve that. So basically the way that GSKY works is that the request comes in. It can be looking at looking for a particular area. We've got a cluster of nodes in the back end that will go through to do what's required to access that data, and just returns, in this case, a simple response in a WMS. We've made it working with the OGC standards, so far with WMS, WCS and WPS, and we've demonstrated that we're able to scale that in the case of the MODIS data, sort of out to more of the global scale. It's one of the key things for GSKY is that having a really good metadata index that's underneath that is part of the reason we're able to very quickly find files that match that user request, and then having that the back-end workers on the high-performance computing side, we're able to quickly process the request and return what's required. As mentioned, we've got WMS, WCS, and we're looking at examples of WPS and putting them into production. And the WPS is not on the production service, although we have demonstrated that capability. So now I'm just going to work through just sort of demonstrating, just visually, just some screenshots of how we're able to, what GSKY can actually do. In particular, just noting that when you do give it a try, we're able to demonstrate that it's performant, and it's actually able to do some of these executions on the fly rather than in situ. So first time I've run this without looking at it as a screenshot, so I didn't actually realise that was a moving image. I thought it was just static shots. But that's an example of using an IPython notebook, just that ability to zoom in, zoom out, and scroll through. And as mentioned, we've been working with Data 61 with the Terrier.js software to make that part of the service for the national map, GeoGlam map, and also in particular some work we've been doing with Geoscience Australia, with the Digital Earth Australia products. At the moment, we've done the WMS data services for them, and just recently released WCS, and working towards the WPS. So if you're interested in how to play with the data using National Map, you just go to National Map on the website, add data, you'll get access to these slides. You then have to put in the GSKY URL at this stage, although there are some data sets that are already linked under the data catalogue associated with National Map. And now just to quickly step through some of the examples of what we've been able to do with the GeoGlam project. This is just a fractional cover product, and it's just showing a single layer. You're able to get down to look at the subsets of the data. When we talk about a layer, there's lots of definitions that we might say is a data set, and then we'll be able to display different views of the data set, which we refer to as a layer. And I think GA, you call it a style. Yes, so we've sort of, but that's when we're meaning the same thing. In case of the surface reflectance, there's the like a true colour and a false colour versions of it. Oops. And then this is just showing you how with the national map, there's I've got a pointer somewhere. There's you can see there's a split screen. Oh, here it is. There's a split screen through there, and on the left-hand side we've got data from 2018, and then on the other side is 2017. And then you can slide, the slider to the right or to the left, so that you can actually then view how something might have changed or what might be different from year to year, or whatever the period is that you're looking at. And then we've sort of found WCS people are still interested in how, like in actually downloading the data, and we've been able to do that now with, for example, getting down to putting in a bounding box, and then saying what it is that the area that you want, and then this is something we've been working on with GA clip and ship, and then that will enable people to actually download that data. And then Clare has already shown you an example of a time series, and we're able to do that using the data services using GSKY in the back end. In this case, it's a polygon around Melbourne, and then it shows the time series at the bottom. So with the Python notebook examples, we've developed a couple already. We're always looking for other opportunities if people have got examples that they want to work with. Please contact us if you've got a problem that you're trying to work with that you think that something like this could help with, because then we can create more examples of these notebooks that can be used by other people. And we're working on our user documentation as well. So at the moment this isn't on our website, but it will be added there soon. If you were interested in trying to work with GSKY, please contact us, and we can give you some more information. And the general contact is the gsky@nci.org.au. And essentially the way that GSKY is currently now available with for the Landsat. Sentinel will soon be on the production service. Modus is currently available from the GeoGlam rack, but it will soon be available from a production GSKY service as well. I'd just like to thank the whole team for the work. It has actually been several years of effort to come up with GSKY, and it's been a team effort from everybody. And with our collaborators, otherwise we wouldn't have that data to play with. Thank you.